All right, we're here with Honor Statistics class, period 2, and we're going to start talking about linear regression. All right, that's what this is all about. This is chapter 8. So anything we do for the rest of this week, today, tomorrow, and Friday, is going to be from chapter 8. So you'll notice you should have already picked up the chapter 8 homework. That is due Friday. What else is due Friday? Your reading guide for chapter 8. For those of you that turn it in late, I'll be grading it tomorrow, giving it back to you tomorrow. All right, so you got less time to do it. Them's the breaks. All right, so here we go. The linear model. The linear model. We've actually already looked at this line, all right, when we went to Desmos and did our correlation coefficient R. But now we're actually going to talk about what it means. Okay? So the whole point of this lesson and this week is to understand what a linear regression model is telling us about the data. So a couple of things you need to know. You already know that when you do this on the computer, it gives you that line that's going through the scatter plot. That is your linear model. Okay. Now, the first thing that's on this lecture is talking about residuals. All right, it's going to be a key thing over the next few weeks. First off, at the very bottom, a residual is equal to the observed y value minus the predicted y value. Okay, so residual is observed minus predicted. And everyone should see that little hat on top of that y. All right, that always means predicted. Anytime you write down a model, all right, one of your variables, the y value, should be the predicted one, should have a hat on it. Yes? An A? What is it? It's like this, a carrot. You're talking about that? Like almost a triangle?
Yeah, it looks like an A.
Got it.
The small one.
Well, an A has a
line. Yeah, blue line.
You gonna make it? Okay. All right, because we still got many months until graduation, and then you got college, and then your job, and then your life, and then you're dead. But that's okay. Here we go. You're almost there. Almost there. Now, I know some of you are in AP Environmental Science, and from a comment that Catherine made last week, it seems like you've already talked a little bit about some of this. You said the line of best fit. Is that what you were talking about? You learned algebra, even better. Okay, maybe not environmental science then, just kidding. Okay, take it back. Dean Feek, assistant. Now, assistant to the dean. Assistant, I got it, okay, assistant to the dean. Now, the reason I put this on this slide here is because there are lots of different ways you can talk about this line. The linear model, the linear regression model, the line of best fit, the least squares line, which I'll go into more detail right now. So if you think back to that one day when we calculated the standard deviations. If you can think back to that one day when we went to our boards and we calculated standard deviations. Remember that day? Okay, so on that day, we always subtracted our data values from the mean, but some of our data values were above the mean and some of our data values were below the mean. All right, so we get positive numbers and negative numbers. And when you add those together, you start to cancel them out. So to avoid that, we squared everything. You guys remember that? We squared everything. So when they find this linear model, this line, they're doing the same thing. They're squaring those residuals. Okay? So that difference between the observed and the predicted, they are trying to minimize those values. All right, so I know when you're doing it on Desmos, you think it happens instantaneously. But if you think about what the computer is actually doing, it's calculating a ton of different lines, and they're trying to find the one that has the least amount when they square all those differences. All right, which is why it's called the least squares line. All right, that's pretty technical and not something you're ever going to be tested on in this class. But if you're all interested in how they calculate it, that's how they do it. Okay? Any questions on that? Why are you looking at me? You can. It's just like I think you go faster if you look there. I am recording, yes. This is Wences. Taking so much time. There, he's done. So proud of you. Okay, now I mentioned this yesterday. You guys remember yesterday when I mentioned you're going to see it both ways, the line? So we have been doing so far y hat equals bx plus a. That's what we've been using over the past week. All right? I know it can be a little confusing because this b, you're used to seeing b as what? M as the slope. So it can get a little confusing. So just make sure you know, here's the way to make it less confusing. Whatever number is next to your x, that's the slope. Okay? The other thing is the y-intercept. So when you're doing this on quizzes or tests for me, I don't care which way you put it. Right? The order doesn't matter to me. If you want to write the slope and then the y-intercept like you've been doing in algebra, totally fine. If you want to do the y-intercept and then the slope, also fine. All right? It's up to you. I'll do it both ways many times so you can see how it's done. Now, the key thing is when you do these, when you write them down, I do want to make sure you write them with their variables as the x and y. So you'll notice there's no y hat and there's no x. It's the actual names of those different variables. All right, so please get in the habit of just writing the names down. So it's going to be kind of funny sometimes when we say like fat hat. That's how you'd say that, fat hat, or predicted fat. No, I thought that was a little funny, but all right. Sorry, be more serious. Okay. Any questions on this? All right, let's keep going. Almost there? Okay. I've mentioned in the past how we need to start thinking about, is it okay to do the things that we're doing? Do you remember last week how I said, you really should not be using the word correlation unless your variables are what? Unless your variables are what? Quantitative. And if your scatter plot, it must show a linear relationship. If you don't have quantitative variables, you should not even be making a scatter plot. And then when you look at the scatter plot, it should look linear for you to use the word correlation. Okay? So those are all some of the checks we've already done. So we're still going to do the same thing. Check, are the variables quantitative? Straight enough condition is the scatter plot linear? And then the outlier condition, just check, are there any unusual features going on? If you're all good there, then you're ready to make the linear model, which we'll do today on Desmos. Okay? Now this right here is something that we're going to mention this week, but really get into it a lot next week. Whenever you make your model, there's always going to be something left over. All right? The residuals. So whenever we make a model today, I'm going to show you how to check what's something called the residuals plot. Because when you check the residuals plot, you're hoping to see nothing interesting going on. All right? And let's think about a scatter plot. What would a scatter plot look like if it was nothing interesting going on? Not a straight line. That would be interesting. If it was linear, I'd be very interested. What would a scatter plot look like that would bore me? You're like, oh, that does nothing for me. A cloud. Very good, right? So when you check the residuals plot, you're looking for no pattern, just a cloud of dots. That's what you're hoping for, because that means then your model is doing a good job of modeling the relationship. If you see a pattern or something going on here, then your model is not doing a good job, and you should not use it. It's inappropriate to use it. Okay? Thank you, Saul. You knew it, right? I always think maybe my seniors will be the ones that don't do that stuff. But no, even today, Saul couldn't handle it, right? In his brain, he was like, oh, I should do it. No, I shouldn't. No, maybe you didn't. Maybe you thought I'm doing it all the time. Okay, right? Just filter it out. Just do it in your head and then laugh in your head. Okay? Tell somebody after school. They're like, oh, man, it was this great joke I told. And that way they don't even know. Okay. Now, you've actually seen this with the output on Desmos. This r squared. You guys, we've seen this already. We haven't talked about it, but it's been there on some of the problems we've done. R squared is a good number to look at to see how good, and I know everyone at home listening can't see what I just did there, but I just did air quotes, how good this linear model is. Okay? Because you should know from our discussion many months ago, a month ago, that any model is wrong. But sometimes a model can be useful. So R squared, we're going to be looking at as another way of seeing, is it useful to use this model? Or is it something I shouldn't really use? Okay? So that's another new thing that we're going to talk about this week. Okay. So let's go ahead and stop here. We'll pause. Let me get the recordings done here. So stay with us because now we're going to do a problem about used Toyota Corollas. See ya!